Okay, let's see how to find the value for the inverse of f of 2 when we are given the graph of the original. So the idea is that the x and y got switched from the original to the inverse. That's the key. Originally, when we have f of x, the number inside is the x, and then the result is the y when we are given this picture. Now, when we have the inverse here, the number inside is the y from this picture. So we are saying that when y is equal to 2, and we will have to find out x will be equal to what. So when y is equal to 2, we look here, this is the graph, and we look down, it's 1. So the inverse of f of 2 is equal to 1. And then we are done. This is how we utilize the graph of the original to find out the value for the inverse. Just like that. And I want to use this opportunity to just go over some of this with you guys for review purpose. If the question was asking us for the original of f of 2, then this is like the normal question. This right here is telling us when x is equal to 2, and we have to find out y is equal to what. When x is equal to 2, look up here, and we see that here is the point, which is 4 for the y. So f of 2 is equal to 4. So they are very different, right? They are very different. And in fact, when we know f of 2 is equal to 4, this right here will also tell us the inverse of f of 4 is equal to 2. Because, again, the x and y got switched. So you see, this right here is when y is equal to 4 and tell us that x is equal to 2 by utilizing this graph right here. That's the key, okay? Now, how would you sketch the graph for the inverse? X and y got switched, and let's do it right here. So I will just say, let's sketch y is equal to f inverse. And now this notation is pretty bad because earlier I said x and y got switched, but when I say x and y got switched, we are referring to the original. Right now we're trying to get a graph for the inverse with this property. There are two ways to do it. The first way is you do the reflection with a paper, but I don't have a paper right now, so let's just plug points. I'll show you guys how to do it. So to make it clear, I'm just going to write down the coordinates of all this. So this coordinate is 0, 1, and then 1, 2, and then 2, 4. And here is negative 1, 1 half. And here we have negative 2, 1 over 4. In fact, this is just 2 to the x. Okay, so how do we graph the original? Let me just put a picture like this. Here we have 0, 1 from the original. If you want to get inverse, you do 1, 0. So let's say here we have 1, 2, 3, 4. 1, 0 is right here. Right? 1, 0. Next, let's look at this. Originally it was 1, 2. Now we will get 2, 1. So 2, 1, right? 2, 1. So it's this point right here, 2, 1. And then it was 2, 4. Right now it's 4, 2. So I will just put a point right here, 4, 2, compared to the original. And then just continue. We will have 1 half, negative 1. So 1 half, it's right in the middle, and then negative 1. So we have a point here. And then lastly, 1 over 4, negative 2. So it's like right here, half of half is 1 over 4. So we have a point right here, like that. And then I'll just connect the dots. Like this. Yeah. And as I said earlier, this right here was actually y is equal to 2 to the x. This graph right here is actually a log graph, right? Y is equal to log base 2 of x. And they are inverse of each other. It's just a reflection about y is equal to x. And this is how you do it though. You can, if you understand this idea, then you can graph any inverse function when the function is 1 to 1. Alright, that's it.